So the melting point of NaCamine is 195.2. The melting point of phosphine is 139.5. The melting point of arsenic trihydride, that is its IUPAC name will be arsine, and melting point of arsine trihydride, that is 156.7, and the melting point of SbH3 is 185. শিনু শর্টস লাইভ না দেখে পড়াশোনা কর, লাইভ দেখছি। কি করবি লাইভ দেখে নানু? লাইভ দিয়ে যা। So the boiling point unit is Kelvin, and it is 258.5. So the boiling point of amine is 138.5, and hydride is 185.5. 185.5. So the boiling point of amine is 238.5, and phosphine is 185.5, and ASH3 is 210.6. 206.6, 254.6, and bismuth trihydride will be 290. Five point two, and for phosphine it will be 139.5. Okay, so for melting point will be 195.2, and phosphine 139.5. For ASH3, that is arsine or arsenic trihydride, it will be 156.7. For SbH3 it will be 185, and for bismuth is taught region in NCERT. So for NH3 it will be 195.2, for PH3 it will be 139.5, for ASH3 it will be 156.7, for SbH3 185, and for bismuth is not given. Now the boiling point, for boiling point unit is Kelvin, and the boiling point is 238.5 for ammonia, and for phosphine it will be 139.5. For arsenic trihydride it will be 156.7, and sorry, for arsenic it will be 210.6. 195.2, 139.5. For estimate 156.7, 156.5, 185. 195.2 for phosphine, that is 139.5. For ASH it will be 156.7. For SBH3 185. So for NH3 it will be 195.2. For PH3 139.5. For ASH3 156.7. For SBH3 185. Mm, so for NH3 it will be 139.5, 156.7, and then 185. For NH3 it will be 195.2. For PH3 that is 139.5. For ASH3 156.7. For SBH3 185. So the IUPAC name of NH3 and the normal name of NH3 is ammonia, and the IUPAC name will be amine. For PH3 that is phosphorus trihydride, sorry, phosphine. PH3 is termed as phosphine and its IUPAC name will be phosphine. For ASH3 it's arsenic trihydride, so its IUPAC name will be arsine. For SBH3 it is its normal name is antimony trihydride and its IUPAC name will be stibine. And for BIH3 that is bismuth trihydride, its IUPAC name will be bismuthane or bismuthine, both are same. The most struggling thing is that when we have to memorize that trihydrides melting points, boiling points, then elements to hydrogen distance, the bond angle. So it's the most challenging one. So for that we have to write it in your copy for multiple time. Okay. I think P block chapter is very challenging because we have to memorize a lot in P block. So for NH3 it will be 195.2. For PH3 it will be 135.5. For ASH3 it will be 156.7. For SBH3 185. For NH3 it will be 195.2. For PH3 it will be 139.5. For ASH3 156.7. For SBH3 185. For NH3 it will be 195.2. For NH3 it will be 195.2. For PH3 melting point will be 139.5. For ASH3 it will be 156.7. For SBH3 it will be 185, and for bismuth it's not given in NCERT. So let me write once again. For NH3 that is amine, melting point will be 195.2. For PH3 it will be 139.5. For ASH3 it will be 156.7. For SBH3 it will be 185. Again I have write. I will cover up this page. I will write this same thing in one page. यार मैं तो ऐसे नहीं पढ़ता हूँ यार, क्या बात है. If you write the challenging thing in your copy for multiple time, like the when we are in class 2 or 3, our parents actually teach us like this: write the thing in your copy multiple time, then only you get memorized. So similar thing I applied for P blocks element, because where we have to, there is inorganic chemistry and inorganic chemistry we have to memorize a lot. So when you write this value in your copy, I think it will be in our memories. Okay, long term memories, it will fit in our long term memories. So for NH3 it will be 195.2, for PH3 it will be 139.7, sorry 139.5, 139.5 for AHC 156.7, for SBH3 it will be 185. So for NH3 it will be 195.2, 195.2. For NH3 it will be 195.2, for PH3 it will be 139.5, for then ASH3 it will be 156 point, yes 6.7, then SBH3 it will be 185. 195.2, for PH3 it will be 139.7, for ASH3 will be 156.7, for SBH3 will be 185, for NH3 will be 195.2, for SBPH3 will be 139.7, 139.5, 156.7, 185. 195.2, for PH3 it will be 139.5, 139.5, for ASH3 will be 156.7, for SBH3 will be 185. So for NH3 it will be 195.2, for 185.2, for PH3 it will be 139.5, for ASH3 it will be 156.7, for SBH3 it will be 185. So for NH3 it will be 195.2, for PH3 it will be 139.5, for 156.7 and 185. So PH3 195.2, then 139.5, 156.7, it will be 185. So the melting point of ammonia is 195.2. For the melting point of phosphine is 139.5. Then melting point of ammonia, sorry, not ammonia. The melting point of uh, arsine is 156.7, and the melting point of bismuth trihydride, and its IUPAC name will be bismuthane or bismuthine. So it will be 185. So I have memorized after writing these in my copy. You can see my copy. I have written the similar things for many times. Now let's memorize the boiling point value. The value of boiling point, the boiling point unit is Kelvin. So for NH3, PH3 that is phosphine, ASH3 that is arsine, IUPAC name is arsine, and its normal name will be arsenic dihydride. Okay, for SBH3 that is antimony trihydride, and its IUPAC name will be stridine. And for BIH3 that is bismuth trihydride, normal name, and IUPAC name will be bismuthane or bismuthine. Now what is the Let me memorize the value of boiling point. Okay, so boiling point for amine is 238.5, for hydride is 185.5, for arsine is 210.6, for SBS is 254.6, and for bismuthane or bismuthine it will be 290. So boiling point of NH3 will be 238.5. For phosphine it will be 185.5. For arsenic 210.6. For SbH3 will be 254.6. For BiH3, that is bismuthane or bismuthine, or it can be termed as its normal name will be um, bismuth. Yes, it is bismuth. So bismuth trihydride. So it will be bismuth trihydride. BiH3 it will be 290 boiling point. So boiling point of the boiling point of NH3 is 238.5. For phosphine it will be 185.5. For phosphine it will be 185.5. For ASH3 it will be 210.6. For SbH3 it will be 254.6, and for BIC it will be 290. So for ammonia, that is amine, it will be 238.5. For pH it will be 185.5. For it will be 210.6, 254.6, and 290. Then for ammonia and for ammonia it will be 238.5. For phosphine it will be 185.5. For arsenic trihydride will be 210.6. Okay, for HbA3 it will be 254.6, and for bismuthane it will be 290. So for ammonia it will be 238.5. For pH3 it will be 238.5, 238.5, and for phosphine it will be 185.5. For ASH3 it will be 210.6. For SbH3 it will be 254.6 and 290. For ammonia it will be 238.5. For phosphine it will be 185.5. Yes, 185.5, then 210.6, 254.6, and 290. So for ammonia it will be 238.5. Then for phosphine it will be 185.5. For ASH it will be 210.6. For SbH3 it will be 254.6. For BISC it will be 290. For ammonia it will be 238.5, 285.5, 210.6, 254.6, 290. For city it will be 210.6. For AU 254.6. then 210.6, and 254.6, then 290. For amine it will be 238.5, then 150, 185.5, 210.6, then 254.6. So for ammonia it will be 239.5, then for phosphate it will be 185.6, and for arsenic trihydride will be 210.6, then 254.6, then 290. So the correct order will be, first one is NH3, then SBH3, then ASH3, then PH3. So the value of amine is 139. The value of amine is, boiling point of amine is 195.2. The boiling point of phosphine is 150, 139.5. Boiling point of arsenic trihydride is 156.7. For SB3 185. 195.2 for boiling point of NH3 will be 195.2. For phosphine it will be 195. Then 139.5 for arsenic trihydride it will be 156.7. For SbH3 it will be 185. And for bismuth is not given. So 238.5 melting point for arsine. Melting point of phosphine will be 185.5. Melting point of ASH3 will be 210.6. SbH3 will be 254.6, and for BiH3 it will be 290. Now EH, that means element and hydrogen distance. Distance here is unit is pm. So for NH3, that is amine, it will be 101.7. For PH3 it will be 141.9. For ACC 151.9, that is 170.7. For BiH3 is not given. So the distance of NH3 will be 101.7. Then it will be 141.9. Then for ASH3 it will be 151.9. For BiH3 it will be 170.7. For NS3 it will be 101.7. For PSC it will be 141.9. For ACC it will be 151.9 and 151.9. Then for HBS it will be 170.7. For NS3 it will be 101.7. For PSC it will be 141.9. ASAC will be 151.9, 170.7. Now the bond angle will be, for NS3 bond angle is 170.8, 107.8 degree. Then for PSC it will be 93.6. For ASAC it will be 191.8 for 91.3. So for bond angle, so the bond angle for NSC will be 107.8, then 93.6, then 91.8, then 91.3. 107.8, 107.8. For NSC will be 107.8. For PSC it will be 93.6, 93.6. For ASAC it will be 91.3, 98.1.8, and then 91.3. 107.8, 93.6, 93.6, 93.8, then 91.9. 107.8. For NS3 it will be 107.8. For PSC it will be 93.6. For ASH3 it will be 93.6, then 93.8. Then for HBSC it will be 93.91.3, not 93, 91. 107.8. Then PSC it will be 93.6. Then for ASH it will be 91.8, then 91.3. One 7.7. For age 100, 107.7, 141.9, 151.9, then 170.7. 101.7, then it will be 101.7, then 141.9, then 141.9, and 151.9, then it will be 170.7. So for the boiling point, for the boiling point of amine will be 238.65, sorry, 238.5. So the boiling point of amine will be 238.5. The boiling point of NH3 will be 238, then 185.5. Boiling point of SH3 is 210.6. Boiling point of SBH3 is 254.6, then 290. So boiling point of NH3 is 239.65. 239.5. The boiling point of NH3 will be 239.5. The boiling point of PH3 will be 239.5, 185.5. Then SBASH3 it will be 210.6. Then for SBH3 it will be, for SBH3 it will be SBH3 it will be 210.6, 254.6. Yes, then for BIH3 it will be 290. For AH3 it will be 239.5. For PH3 it will be 185.5. Then ASH3 will be 210.6. For HBH3 will be 254.6. Then 290. For now, for the melting point 195.2, for 195.2 melting point for NH3, for pH3 that is termed as phosphine, and for phosphine it will be 139.5. Then for HH3 it will be 156.7. For HB3 will be 185. Then 56.7, then 185. yesterday's melting point is 195.2, 39.7, then 156.7, then 156.7, then 185 for BI, 185 for SS3. So melting point will be 239.5, 239.8, yes, 239.5, then 185.5, 210.6, then it will be 210.6. Then for AS, PH3, ASS3, for HBH3, for HBH3 it will be 200, for HBH3 it will be 254.6, and for BIH3 will be 290. Now EH distance, that is electrons to hydrogen distance, that is 101.7 for NH3, 141.9 for PH3, 151.9 for ASH3, and for SBH3 it will be 170.1.7. Yes. Now the bond angle will be 107.8, 93.6 for pH3. For ASH3 it will be 91.8, then 91.3 for SBH3, and BIH3 is not given in NCERT. Now the properties of melting point, 197.5, 139.5. The melting point of this is 195.2, 192, then 195, then 156.5 for 156.7 for ASH3, for SBH3 it will be 185. Now for boiling point, 239, 238.5 or 239.5. For PIH3 it will be 185.5. For ASH3 it will be 185.5, then 210.6, 254.6, then 290. Now for EH distance, 101.7, 141.9. For ASH3 it will be 151.9. For HBH3 it will be 170.7. For bond angle, so NH3 bond angle is 107.8 degree, then 93.6 degree, 90. Then for ASH3 it will be 91.6. Then for HBH3 it will be 91.3. till FH. So the ionization enthalpy for NH3 will be minus 46.1, then KH3 will be 13.4. For ASH3 will be 66.4, for SBH3 will be 145.1, then for BIC will be 278. Minus 46.1 for NH3, ionization enthalpy, then minus 46.1. 13.4 for PH3, 66.4 for ASH3. For ASH3 it will be 66.4, for SBH3 will be 145.1, then for BIH3 will be 278. For NH3 will be 146.1, for NH3 it will be 46.1. For PH3 it will be 13.4, then for ASH3 66.4. For SBH3 it will be 145.1, for SBH3 it will be 145.1, for BH3 will be 278, so minus 46.1 for NH3. Those who are new, please subscribe my channel and give one like to my live. Those who are new, please subscribe my channel and give one like to my live. So minus 36.1, then 13.1 minus 46.1, then minus 46.1, then 13.4, minus 46.1, minus 46.13.4, 66.4, 145.1, 278, minus 46.1, then 13.4, then 66.4, 145.1, then 278. atomic and physical properties. Seventy, 110, 121. For the covalent radius, it will be 70. For phosphorus, 110. For arsenic, it will be 121. For Hb, it will be 141. Then for bismuth, it will be 148. 70, 110, 121, 141, 148. 70, 110, 70, 110, 121, 141, 148. 70, 110, 121, 141, then 148. 70, 110, 121, 141, and 148. So for ionic radius, it will be so for ionic radius, it will be 171 for NH3, 112 for phosphorus, and arsenic 120 and 2 for Hb 176. Let me just so for melting point 63, melting point for two elements, phosphorus 63, then for the nitrogen 63, phosphorus is 317, for arsenic it will be 1089, for Hb it will be 404, for bismuth it will be 544. So the melting point of nitrogen is 63, for melting point of phosphorus is 317. D, and D indicates the white phosphorus. Here the phosphorus used is the white phosphorus. So 63 melting point for nitrogen is 63, melting point of phosphorus is 317 D, and the melting point of arsenic is 1089 E, melting point of Sb is 404, and melting point of Bi is 544. Boiling point of nitrogen is 77.2, boiling point of electronic configurations of group 15 elements. So Balanchine's electronic configurations will be ns2 and np3. So for s orbitals there will be 2 electrons, for p orbitals there will be 6 electrons, for d orbitals there will be 10 electrons, for f orbitals there will be 14 electrons. And for half filled, we know that if we divide that, half filled means there will be half electrons of the total electrons of the orbitals. So the s orbitals in group 15 is full filled. So in the s orbitals in group 15 p block, group 15 includes the p block elements, and the s orbitals in this element is fulfilled, and the p orbitals are half filled. So group 15 electronic configuration is extra stable. Why the group 15 electronic configuration is extra stable is due to the fulfilled s orbitals and half filled p orbitals. So due to fulfilled s orbitals and half filled p orbitals, group 15 electronic configurations is extra stable. Covalence for, and now let's read about 7.13. And it's written in NCERT only. So atomic radius and ionic radius. So covalent and ionics are increase in size down the group. Obviously, as we go down the group, the atomic size increases. Now the covalent radius. For the covalent radius for nitrogen and phosphorus, there is a considerable increasing of atomic size. And for arsenic, then bismuth. So for arsenic, antimony, and bismuth, there will be small increase in atomic size. Okay. So there is a considerable increase in atomic size for nitrogen to phosphorus, and small increase in atomic size from um, arsenic to bismuth. And arsenic to bismuth, this includes arsenic, antimony, then bismuth. Okay. So why their atomic size is increasing like that way? Okay, so because due to completely filled d orbitals in heavier metals and completely filled f orbitals in the heavier metals. So there is a considerable increase in size from nitrogen to phosphorus, and there is a small increase in size from arsenic to bismuth due to completely filled d orbitals in heavier metals and completely filled f orbitals in heavier metals. Completely filled d orbitals in heavier metals and completely filled f orbitals in heavier metals. Okay. Now for ionization enthalpy, so one short trick is that atomic size is inversely proportional to ionization enthalpy. So when there is increasing atomic size, their ionization enthalpy will decrease, and when there is decrease in ionization enthalpy, their atomic size will increase. So ionization enthalpy decreases down the group. Why ionization enthalpy decreases down the group? Because the atomic size, as we go down the group, the atomic size increases. So that's why the ionic size decreases down the group gradually. So it decreases down the group due to gradual increase in atomic size. So in short, we can say that atomic size is inversely proportional to ionization enthalpy. And ionization enthalpy of group 15 elements is much greater than group 14 elements. Why? The ionization enthalpy of group 15 elements is much greater than the group 14 elements. Actually, ionization enthalpy means when we the energy needed to take out the electrons from the orbitals, means the outer orbitals. So energy needed. So group 15 elements is extra stable. So due to it's extra stable because s orbitals is fulfilled in group 15 element and p orbitals is half filled. So this give the electronic configuration extra stability. So that's why the ionization enthalpy of group 15 elements is much greater than the group 14 elements. Okay. The order successive ionization enthalpy as expected, that is ionization enthalpy of H3 is greater than I delta I H2 is then ionization enthalpy. Ionization enthalpy is denoted by I dot E, that is I del I H. So now electronegativity. So in NCERT, is given the electronegativity point. For nitrogen it will be 3.0, for phosphorus it will be 2.1, for arsenic it will be 2.0, for antimony it will be 1.9, for bismuth it will be 1.9. So this is the value. These are the values of electronegativity. So electronegativity decreases down the group with increasing atomic size. So when the atomic size will increase, there will be decrease in decrease there it will decreases down the group with the increase in atomic size. So electronegativity decreases down the group with increase in atomic size. So similarly, we can say that atomic size is inversely proportional to electronegativity. Amongst the heavier elements, the electronegativity difference is not that much pronounced. Okay, amongst the heavier elements, the electronegativity is not that much pronounced. Means don't have a much difference between the between their electronegativities, though they are the heavier element because their mass number is increasing. So among the heavier elements, what are the heavier elements? The heavier elements may be the heavier elements are, like you can consider antimony, then bismuth. So their mass number is higher. For bismuth, its mass number is 100. Its atomic number is 105 and its mass number will be 208.9. And for Sb, that is the antimony, its mass number is atomic number is 51 and its mass number is 121.5. So they are considered as the heavier metal. Not Sb is not the metal. Bismuth and moscovium is the metal. So Sb and bismuth, they are having atomic mass is larger, so their electronegativity is smaller. Now the physical property of group 15's elements are all the elements, that is nitrogen, phosphorus, all the elements of group 15's, and the group 15's elements include nitrogen, phosphorus, arsenic, then arsenic, antimony, then bismuth. Are the groups of, they are polyatomic, so they can form the polyatomic dinitrogen. So nitrogen is considered as gaseous form, but except nitrogens, all are in the solid form, like now phosphorus, arsenic, then antimony and bismuth, they are in solid form. Okay, so down the group metallic character increases obviously down the group. So the nitrogen and phosphorus, they are the non-metals. Then arsenic and bismuth, they are the not bismuth, sorry, arsenic and antimony, they are the metalloids, and bismuth and moscovium, they are the metals. It's due to the ionization enthalpy decreases, and the reason is that this is due to decrease in ionization enthalpy and increase in atomic size. Decrease in ionization enthalpy and increase in atomic size. Decrease in ionization enthalpy and increase in atomic size. So as we down the group means from top to bottom of the periodic table. So the boiling point it gradually increases, and for melting point, for nitrogen to arsenic it increases, but for Sb to bismuth it decreases. For the melting point, for nitrogen to arsenic the melting point increases. For nitrogen to arsenic melting point increases, and for Sb to bismuth the melting point decreases. Except nitrogens, all the group 15 elements show allotropy. So except nitrogen. So what are the group 15 elements? So except nitrogen, the group 15 elements are phosphorus, arsenic, antimony, bismuth. Okay. So except nitrogen, all the group 15 elements, they show allotropy, and that is written. Okay. So melting point actually increases from nitrogen to arsenic and from